Hello everyone. In this class, we'll learn about spinal reflexes. The learning objectives of this class would be to name the spinal reflexes, draw the schematic diagrams of stretch reflex and inverse stretch reflex and explain their importance in motor functions, understand the importance of withdrawal reflex, list the difference between stretch and withdrawal reflexes, explain the significance of mechanism of after discharge of withdrawal reflex, mention the properties of spinal reflexes, and understand the mechanism of inhibitions in the spinal cord. Spinal reflexes play a crucial role in the control of posture and movements. Many posture regulating mechanisms control motor functions mainly by altering the threshold and sensitivity of the spinal reflexes. A spinal reflex is defined as a stereotyped motor response to a specific stimulus like stretch of the muscle. Typically, the spinal reflexes include receptors, afferents, interneurons, motor neurons, and the muscle. The reflexes are integrated in the spinal cord are the stretch reflex, which is also called as myotatic reflex, inverse stretch reflex, which is also called as inverse myotatic reflex, withdrawal reflex, which is also called as flexion reflex, positive and negative supporting reactions. The last two reflexes are not observed in normal subjects, rather they can be elicited in a spinal human or animal. So this is the reflex arc for any reflex. It has a receptors, afferents, and integrating neurons as a motor neuron and interneurons. Then the effector organ, the muscles. Coming to stretch reflex, the reflex contraction of the muscle to stretch when a skeletal muscle with its intact nerve supply is called a stretch reflex. The stretch reflex is the key reflex in the regulation of posture and movement. Stimulus is the stretch of the muscle and response is the contraction of the stretched muscle. The stretch of the muscle initiates activities in the afferent nerves that directly stimulate the motor neurons. Therefore, stretch reflex is a monosynaptic reflex, that is, a single synapse between afferent and efferent limbs. There are two types of stretch reflexes, phasic stretch reflex and tonic stretch reflex. Phasic stretch reflex is elicited by stimulating the primary endings of the muscle spindle. Here, stimulus is the sudden stretch of the muscle. The reflex arc for this phasic stretch reflex, where receptors are muscle spindle and afferent is group 1A fibers. In the spinal cord, afferent nerves divide into two main branches. One of the branches of 1A fibers directly terminates monosynaptically on the homonymous motor neurons, that is on the motor neuron that supplies the protagonist muscle, and the other branch terminates disynaptically via an inhibitor interneuron, that is Golgi bottle neuron, on the heteronymous motor neuron, that is the motor neuron supplying the antagonist muscle. Thus, activity of 1A fiber stimulates the homonymous motor neuron that causes contraction of the protagonist muscle and inhibits the heteronymous motor neuron that causes relaxation of the antagonist muscle. Therefore, when agonist muscle contracts, simultaneously the antagonist muscle relaxes. The relaxation of antagonist muscle facilitates the movement caused by contraction of agonist muscle. Such an innervation that ensures the activation of set of motor neurons and inhibition of another set of motor neuron is called as reciprocal innervation, and the inhibition of antagonist muscle is called as reciprocal inhibition. The function of this stretch reflex, the reflex contraction of the muscle in response to a sudden stretch, is the phasic stretch reflex. The phasic reflex contraction results in rapid limb movement. The examples are tendon reflexes. The tendon reflex is elicited by tapping the tendon, which provides a quick stretch of the muscle. By making rapid and transient movements, phasic stretch reflex ensures immediate corrections of the spinal motor output in the moment-to-moment motor control. Clinical significance. The tendon reflex reflects the general excitability of the motor neurons. When the excitability of the motor neurons is altered in different pathological conditions, the tendon reflexes are depressed or exaggerated. This helps the physician to diagnose the nature of neurological deficit based on the response of tendon reflexes. Especially, the excitability of the gamma motor neuron is more important as it controls spindle sensitivity. Exaggeration of tendon reflexes is an index of increased gamma motor neuron discharge, and depression of reflex indicates decreased gamma motor neuron activity. So this is diagram showing the stretch reflex and the reciprocal innervation. So whenever the muscle is stretched, the IA fibers they are stimulated, and they are going to act on the anterior motor neuron, and that causes the reflex contraction of the extrafusal muscle fibers. Simultaneously, there will be activation of the interneuron also, so which are going to act on the motor neurons of the extensors, and they are going to cause a relaxation of the antagonist muscle, and this is called as reciprocal innervation. Coming to the tonic stretch reflex. So in the tonic the stretch reflex is elicited by sustained stretch of the muscle, where the reflex arc is same as that of a phasic reflex, except that the receptors are both primary and secondary endings. Therefore, the afferents are both IA and two afferent fibers from the muscle spindle. Group 2 afferents make direct connections with alpha motor neurons, and thus this is also a monosynaptic reflex. The function of this tonic reflex is that it contributes to the muscle tone. Muscle tone is nothing but it is the resistance of a muscles to stretch, and tonic reflex is also important for regulation of posture. To maintain standing position after assuming the position, the extensors of the knee should contract so that the knees remain extended and legs do not bend. This is achieved by the action of gravity on medial extensors of the thigh. Due to the effect of gravity, extensor muscles, that is anti-gravity muscles, are stretched. The sustained stretch of extensor results in sustained contraction of these anti-gravity muscles that maintains the extension at the knee joint. Thus, the standing position is maintained. After assuming standing posture for a longer duration, fatigue sets in. Due to the fatigue, gradually the knees bend, and that further stretches the quadriceps muscles. The flexion at the knee joint elicits additional tonic stretch reflex that in turn causes added sustained contraction of quadriceps. This maintains the further extension of the knees and prevents the person from falling. Thus, stretch reflex helps to maintain the posture for a very long period. For example, a traffic police who is standing for a longer duration flexes his knees due to the physical fatigue. This stretches his quadriceps and elicits tonic stretch reflex. Contraction of quadriceps opposes the flexion at the knee and restores his posture. Thus, tonic stretch reflex maintains posture. In summary, the phasic stretch reflex mediates tendon jerk and controls the rapid correction in motor output, whereas tonic stretch reflex maintains body position despite alteration in load on the body. Inverse stretch reflex. Relaxation of the muscle in response to a strong stretch is called as inverse stretch reflex. This is also known as autogenic inhibition. Here, the receptors are the Golgi tendon organs, and these are net-like collection of knobby nerve endings located in the fascicles of tendon. These are 2 to 25 muscle fibers per tendon organs. The stimulus for the inverse stretch reflex is a strong stretch. A active muscle contraction also elicits this reflex. The afferent fibers, from usually the Golgi tendon organ are the 1B fibers. 1B fibers terminate on the inhibitory interneurons that in turn project to the homonymous alpha motor neurons. This results in inhibition of agonist muscle, and this is a disynaptic or bisynaptic reflex. So here the autogenic inhibition reflex, when the muscles are excessively contracted, the Golgi tendon organs are stretched, and usually the 1B fibers are the afferent fibers, and from there they go to the interneurons, and they are going to uh, produce inhibitory neurotransmitter on the anterior motor neuron, and that is going to relax the muscle fiber. The Golgi tendon organ monitors the force developed in the muscle, that is its function. The force is detected either by strong stretch or by an active contraction. The stimulation of the Golgi tendon organ inhibits the agonist muscle through its reflex connections. The agonist muscle relaxes in response to activation of Golgi tendon organ. Thus, a stronger stretch imparted on the muscle automatically inhibits the muscle. Therefore, the reflex is also called as autogenic inhibition. Physiological importance is, as we know, that muscle spindle monitors the muscle length, and the Golgi tendon organ monitors the muscle tension, that is the force of contraction. Thus, the muscle spindle provides length feedback and the Golgi tendon organ provides force feedback. Stretch reflex and inverse stretch reflex, by acting together, maintain the optimal motor responses, that is of muscle tension and muscle length for the postural adjustments. Inverse stretch reflex, by allowing the muscle to relax, prevents rupture of the muscle when the muscle is stretched to greater extents. Effect of gamma motor neuron on the stretch. That is the effect on stretch reflexes and the muscle tone. That is the effect of gamma motor neuron. The gamma motor neurons control the activity of stretch reflexes by altering the sensitivity to muscle spindle to stretch. The spindle afferents do not influence the activities of gamma motor neurons as they have no direct contact with them. However, descending influence from supraspinal segment increase the discharge of gamma motor neurons, which in turn increases the sensitivity of the spindle to stretch. In upper motor neuron paralysis, for example, following spinal transaction, in the recovery phase, the increased gamma motor neuron discharge due to the loss of inhibitory suprasegmental inputs on the gamma motor neuron increases the reflex activity. The muscle becomes hyperactive due to the increased phasic stretch reflex activity and becomes hypertonic due to the increased tonic stretch reflex activity. Muscle tone. Resistance to the muscle to stretch is called as tone. The muscle becomes hypotonic or spastic when the resistance to stretch is more due to the hyperactive stretch reflexes, that is because of increased gamma motor neuron discharge. The muscle becomes hypotonic, that is flaccid, when the motor neurons supplying the muscle are damaged or when the discharge of gamma motor neurons is reduced or decreased. Clasp knife phenomenon. When hypotonic muscle seen in upper motor neuron paralysis is stretched, the muscle contracts, but if the stretch is continued, then the muscle relaxes. For example, flexing the elbow of such a patient first meets with a greater resistance, but if the flexion continues, then the muscle relaxes and suddenly the resistance force disappears, that is flexion occurs easily, and this is called as clasp knife phenomenon. So this type of high resistance followed by sudden collapse is known as clasp knife phenomenon, as it resembles the closing of a clasp knife. Physiologically, this is called as lengthening reaction, as the response occurs due to the lengthening of spastic muscles. Physiological basis for clasp knife. As the muscle tone is more, resistance against the flexion of the limb is more. However, when flexion is continued, further stretch of the triceps muscle activates inverse stretch reflex that relaxes the muscle due to the autogenic inhibition. Thus, the resistance force against flexion suddenly disappears. Clonus. This is defined as a regular rhythmic contraction of a muscle subjected to a sudden maintained stretch. The best example is ankle clonus. This is elicited by dorsiflexing the foot and trying to maintain the dorsiflexion, which results in rhythmic plantar flexion at the ankle. It is typically seen in upper motor neuron paralysis in which spindles are hyperactive. When the muscle is suddenly stretched, the spindle discharges and muscle contracts. Muscle contraction stops, the spindle discharge and muscle relaxes. But maintained stretch stimulates the spindle again and the process is repeated. Coming to withdrawal reflex. Withdrawal reflex is an example of polysynaptic spinal reflex. This is also called as flexor withdrawal reflex because activation of it causes withdrawal of the body parts by flexing the limbs. The receptors are here the nociceptors that are present in the skin, muscle, tendon or joints. Noxious, painful stimulation of the skin, subcutaneous tissue and muscle elicits this reflex. If you see the reflex circuit, the afferents are called as flexor reflex afferents. This includes type 3 and type 4 somatic afferents. The afferents after entering the spinal cord divides into two branches to terminate on two separate sets of interneurons. One branch activates the set of interneurons that in turn excites alpha motor neurons supplying the flexus muscles of the same side. Another branch activates separate set of interneurons that in turn inhibits alpha motor neurons supplying the same side of extensor muscles. A branch of interneuron, that is the commissural interneurons excited by the FRA, crosses the midline to enter the opposite side of the ventral horn and terminate on the opposite set of the interneurons. So that means the commissural interneurons activate the interneurons that in turn stimulate the motor neurons supplying the contralateral extensor muscles and activate interneurons that in turn inhibit motor neurons supplying the contralateral flexor muscles. The response of withdrawal reflex is as per the connections described above. There will be stimulation of the flexor reflex afferent causes flexion of the ipsilateral limb due to the activation of the flexor group of muscles and inhibition of extensor group of muscles. If the stimulus is stronger, extension of the contralateral limb occurs due to the activation of extensor group of muscles and inhibition of flexors group of the muscles. This opposite pattern of action in the opposite limb is called as cross extensor reflex or Philipson's reflex. The flexion response of ipsilateral limb results in withdrawal of the body parts from the source of noxious stimulus, and the extension of the opposite limb maintains the balance during the act. There can be widespread response if the stimulus is still stronger and impulse radiate upwards and downwards in the spinal cord and activate motor neurons that supply muscle of the other limbs to produce widespread response. This results in extension of the other limb of the same side and the flexion of other limb of the opposite side. So this is the one of the example for irradiation of impulse in the spinal cord generated by the stimulus and also of the recruitment of motor neurons of motor units. This is also example of divergence of impulses in the spinal cord. That is, impulses from the afferents project to the mini interneurons and motor neurons in the spinal cord that finally results in flexion of the same limb and with extension of the opposite limb and extension of the other limb of the same side and flexion of the other limb of the opposite side. Various patterns of these limb movements provide postural support and balance for immediate and appropriate withdrawal of body parts. Okay. So this is the withdrawal reflex. So when the nociceptors they get stimulated, okay, so it is going to cause a stretch reflex, that is the flexion reflex, so which is going to cause the, the flexion of the contraction of the flexor muscle, and they are going to inhibit the extensor group of muscles through the interneurons. Okay. And if the stimulus is strong, it is going to irradiate and it is going to cross the opposite side of the spinal cord, and where they are going to inhibit the flexor group of muscles of other limbs, and they are going to facilitate the contraction of the extensor group of muscles. Okay, so which ultimately will be helpful in the balance of the body. Some of the special features of withdrawal reflex. They are protective reflex. The withdrawal reflex is protective reflex and protects the body parts from the damage caused by noxious stimuli. Flexion of the stimulated limb withdraws the limb, and the extension of the opposite limb supports or balances the body. The withdrawal reflex is prepotent. This means when this reflex is activated, temporarily the other reflex activities in the spinal cord almost stop at the moment, so that the spinal cord carries out the reflex responses precisely and without delay. So there is a local sign. The pattern of response of flexor withdrawal reflex depends on the nature and location of the stimulus. For example, abduction occurs when the medial surface of the limb is stimulated, and adduction occurs when the lateral surface is stimulated. So this is called as local sign. After discharge, a stronger stimulus not only causes widespread response but also prolongs the response. The prolongation of response due to the prolonged and repeated firing of the target motor neurons, and this process is called as after discharge. After discharge occurs because of the two mechanisms, that is, first one is involvement of many interneuronal pathways of different length between afferent and different neurons. The pathways containing less number of interneurons stimulate the motor neurons early, and the pathways containing more interneurons stimulate the motor neurons later, and thus the motor neurons are stimulated repeatedly. And secondly, also because of the presence of reverberating circuits in the interneuronal pathways in the spinal cord. The branches of the interneurons project onto the other interneurons that project back to the same interneurons. Thus, the stimulation of the interneurons reverberates the impulses circuitously. Therefore, the motor neurons are stimulated repeatedly. Okay. So this is how when particular motor neurons are stimulated. Okay. So they are going to stimulate the other neurons, and they give collaterals to the other neurons, which gives again collaterals to the same neurons which are previously stimulated, and they will form reverberating circuit. Okay. So that is responsible for the after discharge. So these are the difference between some differences between stretch reflex and the flexion reflex, where in the stretch reflex receptors are muscle spindles, and here they are nociceptors. Afferents are 1A fibers here, and for the flexion reflex they are flexor reflex afferents. In the flexion reflex there is a widespread divergence, and in the stretch it is less. Latency is short for stretch reflex and long for flexion reflex, as they are polysynaptic. Target muscle is the same muscle which has been stretched in the stretch reflex. In the flexion reflex, the flexor muscles of the same side and the extensor muscles of the opposite side. In stretch reflex, there is a single reciprocal innervation, where in flexion reflex, the double reciprocal innervation is seen. Stretch reflex, linear or stereotyped response is seen, and in flexion, it can be non-linear and sometimes widespread. The duration in the stretch reflex, uh, the reflex stops as the stimulus is withdrawn, but in the flexion reflex, the reflex activity continues even after the withdrawal of the stimulus, and this is occurs due to the after discharge. And stretch reflex is specific to a stretch of muscles, where it is not specific in flexion reflex. Local sign is absent in stretch reflex, but it is present in the flexion reflex. And the stretch reflex is not prepotent, where the flexion reflex is prepotent. Properties of spinal reflexes. First one is adequate stimulus. Quality of stimulus that evokes a reflex response is a very precise one. So this is called as adequate stimulus for that particular reflex. For example, stretch of the muscles is the adequate stimulus for stretch reflex. So there can be convergence. The convergence literally means mini one to one projection. This is defined as the termination of several neurons on one target neuron. For example, mini group of 1A afferent fibers from muscle spindle of a particular muscle converging monosynaptically on a single alpha motor neuron. There can be divergence, that it literally means one to many projections. This is defined as the termination of single neuron on many target neurons. For example, the divergence is the termination of flexor reflex afferent on many motor neurons via different sets of interneuron in the spinal cord. So there can be facilitation. Convergence provides a physiological basis for facilitation. Activities in the single afferent fibers may not be able to excite the target motor neurons, but when many afferent neurons projecting on a single motor neuron are stimulated simultaneously, the motor neuron is activated. So this is called as facilitation. There can be inhibition. Inhibition means decrease in the activities of the target neurons. An example of inhibition is the reciprocal inhibition in the spinal cord. Another example is Renshaw cell inhibition. The motor neurons in the ventral horn give collateral to the interneurons that in turn project back to the same motor neuron, and the interneurons, which are called as Renshaw cell, inhibit the output of the same motor neuron that stimulates them. Okay, and this is called as Renshaw cell inhibition. The inhibitions are classified as a direct, that is postsynaptic, and indirect, presynaptic inhibition, or uh, uh, that, for example, Renshaw cell inhibition and feed forward inhibitions. There can also be summations. There are two types of summation: spatial and temporal. Spatial summation, if the strength of the stimulus arriving at the synapse from an afferent neuron is not adequate, target motor neurons is not activated. However, it brings the target neurons to subliminal fringe. If other afferent neurons arriving at the same target neuron are stimulated simultaneously, the activities are said to summate on the target motor neuron and motor neuron discharges, and this is called as spatial summation. Temporal summation is when the impulse arriving on one afferent neuron may not be able to stimulate the target neuron, but when the same afferent neuron is stimulated repeatedly in a rapid succession, the target neuron is activated, and this is called as temporal summation. So there can be occlusion as well. When one afferent neuron is stimulated, it activates the motor neurons that are present in its discharge zone and brings the motor neuron to partially excited state that are present in the subliminal fringe zone. So when the discharge zone of the neighboring afferent neurons overlaps, that is, occlusion occurs. And when the discharge zone of the neighboring afferent neurons overlap, the facilitation occurs. So this occurs in simultaneous activation of many closely situated neurons that have overlaps of their zones. So there can be habituation. Usually the reflex responses are stereotyped. However, with experience, the reflex can also be modified. So this is called as habituation. Habituation and sensitization forms the physiological basis of learning and memory in the CNS. Sensitization is decreased response to the target neuron to an afferent stimulation when the stimulus is applied repeatedly. Okay, and they can have a final common pathway. The motor neurons that supply the skeletal muscle, especially alpha motor neurons, are considered to be the final common path for the motor output. This is because all the neural influences arising from the different parts of the CNS regulate muscle activity through these motor neurons, that is the final common pathway. So this is about the reflex in brief and the properties of the different properties of reflexes. Thank you.